Hi there. Today's show is on a very special subject. It's all about the different ways things move and why sometimes they don't. Things move in many different ways. They can travel in a straight line, they can move back and forth, roll, turn, slide, or they can come to a very quick stop, or just sit still and not move at all. Why do things move or not move? Why do things start and stop? I was curious, and when I'm curious, I need answers. When something moves, we call it motion. When you're riding your bike, you are in motion. When you are rollerblading, you are in motion. The truth is that you are always in motion, even when it seems like you are standing perfectly still. Why? Because the whole Earth is always moving through space. As long as you're on the Earth, you are moving right along with it. That's the funny thing about motion. You can only really tell if something is in motion by looking at the things around it, like riding in a car. If you're standing on the side of the road, it sure seems like these cars are moving pretty fast. But if you're in the car, it feels more like you're the one standing still. That's because everything in the car is moving right along with you. But what makes motion happen? Why do things start moving in the first place? The answer is forces. A force is a push or a pull. Nothing moves without a force pushing or pulling it. Here at this racetrack, powerful engines create enough force to push these motorcycles forward incredibly fast. When I swing a golf club, the force of the club moving very fast pushes the ball in the direction I want it to go. Well, almost. And if I want to bowl a bowling ball, I need to use force to start the ball moving down the lane. If I've done it right, the force of the ball will create motion when it hits the pins at the other end. So I think you get the idea. For things to be in motion, there needs to be force. So what kinds of forces are there? And how do they affect motion? Let's take a look. Of course, you know that when you drop something, like say an apple, it falls down toward the ground. That's motion too. The apple moves when you let go of it. The force that causes this motion is called gravity. Gravity is a pulling force, and it works on everything in our world all the time. Did you ever jump on a trampoline? It's lots of fun. And you can see that it involves a lot of motion. But without gravity, you would bounce once and never come down again. Gravity pulls you down, so you can bounce over and over again. So it's pretty clear. Gravity is a force that causes motion. What about forces that stop motion or slow things down? When I'm ice skating, you can see that I'm in motion. That's because my skates slide very easily over the ice. But when I want to stop moving, I can turn my skates sideways. Now they don't slide so easily anymore, and I slow down and stop moving. I used a force called friction to stop my motion. Friction is all around us whenever things touch. Even when I'm skating, moving freely across the ice, there is friction between my skates and the ice, slowing me down. That's why I need to keep pushing off as I skate. If I stop pushing, friction will slow me down until I stop. Friction is a force that opposes motion. Okay, so we know that there are forces that cause motion, like gravity, and forces that oppose motion, like friction. But what's the story with stuff that's just sitting around, not moving and not bothering anyone? What you need to remember is this: a burger, this car, these plastic cups, for that matter, anything that is not moving, will stay just where it is until a force comes along that either pushes or pulls it. When that happens, it will start to move. The truth is that when things are standing still, there are forces at work. It's just that the forces are balanced. They are equal, like the cups. As they sit here on this counter, we know that the force of gravity is pulling on them, right? So if gravity causes motion, why aren't they moving? Because another force, the force of the counter, is balancing against the force of gravity. When forces are balanced, there is no motion. If I use force to push the cups, they move. And if I push them all the way off the counter, there is nothing to balance against the force of gravity, and they are pulled to the floor. When forces are out of balance, there is motion. Oh, and by the way, when the cups land, the force of the floor now balances the force of gravity, and once again, no motion. Did you ever build a house of cards? It's a little tricky, but it's also a perfect way to think about forces being in balance. This is Jill. As she sets up the cards, gravity is pulling down on them. They will only stand up if she can balance each card against the other, and against the force of gravity. When the forces are balanced, the tiny house will stand. But any move from Jill that upsets those forces, like if she pushes down just a little too hard with her hand and, the house collapses. So motion depends on the balance of forces. I hooked these monster Jeeps together to prove the point. When the drivers race their engines and the Jeeps pull against each other with equal force, no one moves. But if one Jeep pulls just a little harder, then the forces are no longer equal. They are unbalanced, and the Jeeps start to move. I was a happy camper. These ideas of motion and balance were beginning to make real sense. What have we learned about motion and balance so far? We learned that when something moves, it is called motion. And for motion to happen, there needs to be force. A force is a push or a pull. Some forces cause motion, like gravity, and some forces oppose motion, or slow things down, like friction. When forces are balanced, there is no change in motion. When forces are out of balance, there is motion. Here's a fun way to test the idea of balance and how balance is related to motion. All you'll need are a thick, long rope and about 8 or 10 friends, some big and some small. You should do this in a safe area that has grass and also some pavement. And you'll probably want to have an adult along to act as a referee. You may have already guessed that we're going to be doing a tug of war, right? So first, let's just try the basic setup. Split up the kids into 2 equal groups, with each having about the same size kids in each group. Lay the rope out on the grass and put one team on each end. Both teams pick up the rope and get a good grip. Now have your handy adult stand in the middle and give the go signal. Each team pulls on the rope, trying to pull the other team across the center line. Your classic tug of war, right? So what is happening? Well, if the teams are equal in number and size, probably not much. That's because the sides are balanced. There's equal force on both ends. And as we've already learned, when forces are balanced, there's no motion. Now, let's try changing the balance and see what happens. The most obvious way to do that is to put more kids on one team. Try maybe 5 on one side and 2 on the other and see what happens. Okay, so you've guessed that the side with more kids would win easily. But the thing to notice here is that when the sides are out of balance, we have motion. The rope is quickly pulled to the stronger side. So, is changing the number of people on the teams the only way to change the balance? Let's try something different. Take the rope to the edge of the grass and place the middle where the pavement meets the grass. Now go back to your original even teams. One team should be standing on the grass and the other on the pavement. Now, give the go signal and see what happens. Remember, when these teams were both on the grass and evenly balanced, there was very little movement. But what's different now? There's definitely movement. That must mean, right, the sides are out of balance. But this time, it's not the teams that are different, it's the ground they're standing on. Let's check the instant replay. The team on the pavement was able to dig in and pull better than the team on the slippery grass. Their feet just slid along the surface. So what have we learned? Besides how to win at tug of war, that is. Well, the key thing to remember is that when forces are in balance, like when our teams were equal and on the same kind of ground, there is no motion. Things just stay still. But when forces are out of balance, like when we changed the teams or the ground they were on, there is motion. Pretty simple, huh? What makes things stay balanced? If I try to walk a tightrope, or in this case the edge of a bowling lane, I start to fall to one side or the other. As always, gravity is pulling down on me. If I start to fall and don't move to change my balance, I'll fall off to one side. Luckily, every object, including my body, has something called a center of gravity, the spot where all the weight balances. If I keep my center of gravity right over my feet, I can stay balanced. Like when you play on a seesaw. If the seesaw center of gravity is right in the middle, over the bar, the seesaw balances on the bar. But what would happen if one person moves closer to the bar? The weight is still the same on both sides, but the seesaw's center of gravity has moved, and the seesaw does not balance on the bar. So we can see that an object's balance is definitely affected by its center of gravity. Here's a neat thing about balance. You can use motion to help keep your balance. Take riding a bike. When you're just starting out and moving very slowly, it's tough to stay balanced. It's hard to keep the center of gravity in the center over the tires of the bike. That's why we start out with training wheels. But once you get moving, you can stay balanced more easily. The force of your motion is working against the force of gravity, pulling you down. It helps keep your center of gravity, well, in the center. These high-speed motorcycles are another good example. Obviously, the riders need to stay balanced to ride. That's not too tough when they're sitting straight up and going in a straight line. But to go around a corner very fast, they have to lean way over. This puts their center of gravity way out to one side, not over the tires. You would think that the force of gravity would pull them to the ground, right? Well, it would, if it weren't balanced by the motion of the motorcycle as it goes around the curve. The force of the bike moving in a circle is so strong that it works against the force of gravity and keeps the bike from tumbling over. Earlier we learned about friction, a force that slows down or stops things in motion. Can you think of any other ways to stop something in motion? When things are in motion, they generally keep moving until something stops them. When a baseball is hit high in the air, it starts out headed for the sky. Why doesn't it reach the sky? And what finally stops its motion? Well, we know that gravity pulls it back down toward the ground, but that's really just a change in direction. The ball is still moving as it falls. The ball only stops moving when it hits the ground, or when a fielder catches it. Everything that's moving will keep moving at the same speed and in the same direction until a force makes it change. When I putt these golf balls, they move in the direction I push them. I bet you didn't realize that they would keep going forever if something didn't slow them down and stop them. Like the friction of the grass as the ball rolls, or if they bump into something along the way, or sometimes if I get them in the hole. Yay! Understanding motion, how and why things move, can actually save people's lives. When a moving car hits a wall, it stops very suddenly. But a person riding in the car will keep moving, like this test dummy. Without something to stop them less suddenly, they would slam into the dashboard and windshield of the car. Years ago, people who make cars figured this out, and they invented seat belts and airbags to stop people safely in a car so they don't get hurt. That's the same idea with car safety seats for little kids. It's all about controlling motion so people don't get hurt. Did you ever try to stop something in motion? Like catching a baseball, or coming to a quick stop in a car, or stopping your bike. Some things are easy to stop, and some things are hard to stop. It really depends on how big the thing is and how fast it's moving. We call that momentum, how hard it is to stop something that's moving. When you're riding your bike, it's harder to stop when you are riding fast than when you're riding slow. That's because the faster you are moving, the more momentum you have. When I bowl a bowling ball, it has enough momentum to keep going when it hits the pins. It just knocks them over. But the momentum of the ball is no match for the wall at the end of the lane. The wall stops the motion of the ball. If I hit a golf ball with a club, the momentum of the club is too much for the ball. The club keeps moving and the golf ball goes flying. Now the ball has momentum too. On the other hand, if I were to hit a bowling ball with my golf club, well, the heavier bowling ball would definitely stop the momentum of the club. When things are in motion, it takes another force to slow them down or stop them. Here's an important fact about motion that you probably already know. Every motion in one direction causes an equal motion in the other direction. It's true. This is a kayak, and it's just about the smallest boat there is. When the person in the kayak pulls backward with the paddle, the kayak moves forward. And when he pushes forward, the kayak moves backward. It's the same with skating. Remember, I have to push backward against the ice to move forward. Now here's the really amazing part. This idea of equal motion in the opposite direction is what makes it possible to launch huge rockets into space. The force of the fuel burning and pushing down is able to lift the rocket in the opposite direction, up. Okay, let's do a final check of what we've learned today. First, motion is caused by forces, pushes and pulls. We learned that motion depends on the balance of forces. When forces are balanced, like the Jeeps we saw, there is no motion. When forces are out of balance, there is a change in motion. Motion depends on balance. But we also found out that balance can depend on motion, like when we ride a bike, or even when a racer rides a high-speed motorcycle. The force of motion can work against the force of gravity, balancing it out and helping to keep us from falling. We learned that all objects have a center of gravity. That's the spot where all the weight of an object balances. By moving the center of gravity, we can make it balance or not balance. And we learned that when something is moving, it will stay moving forever at the same speed and in the same direction until some other force changes its motion. Finally, we learned about momentum, how hard it is to stop something that's moving. It depends on how big an object is and how fast it's moving. So with all that we learned about motion and balance today, you'd think that I'd be able to skate like a champ, right? Well, understanding motion and balance and mastering them are two different things. I think I left out one very important point. Practice, practice, practice. Oh well, gotta go. See ya.